Hey scholars, congrats on making it through Unit 1. Now it's time for Unit 2. We're going to focus on the quadratic function family. So we're going to talk about all the ins and outs of quadratic functions, and today for our first lesson we're going to talk about the vertex form of quadratic functions. So take good notes and do your best to pay attention and follow along. Let's get started. So remember, the graph of a quadratic function makes a parabola, that U shape that you can see right there in that graph. Quadratic functions can be written in two forms. They can be written in vertex form, which is f of x equals a times x minus h squared plus k. That should look familiar to you. You can actually identify the transformations of the parent function. In standard form, f of x equals ax squared plus bx plus c. Today we're going to focus on vertex form, and we will talk about standard form in the future. This form vertex form because it's really easy to identify the vertex. The vertex of a quadratic function is the highest or lowest point of a quadratic function, and it has coordinates hk. So let's look at this formula here and recall that a is going to tell us if there has been a reflection across the x-axis. So that happens if a is negative, there's a reflection. And it also can tell us if there has been a vertical stretch or compression. If the absolute value of a is greater than 1, then there will be a vertical stretch. If the absolute value of a is in between 0 and 1, so like a fraction or a decimal, like 1/2 or 0.3 or something, there has been a compression. Remember, h indicates a horizontal translation, and k indicates a vertical translation. Now h and k are going to also help us identify the coordinates of the vertex of a quadratic function. Also, parabolas can either be concave up or they can be concave down. You see, concave up looks like a U is for up, and concave down is just facing downwards. We'll talk about that a little more here in a little bit. A key feature that we'll see a lot when we talk about quadratic functions is called the axis of symmetry. Every quadratic function has an axis of symmetry that divides the parabola into two congruent halves. So if you fold it over the right half over onto the left half, it would match on completely. The axis of symmetry always passes through the vertex of the parabola. So this vertex, it has the coordinates of 3, -4, and the axis of symmetry is defined by the line x equals 3. Now remember, the vertex has coordinates hk, that's the general form of the vertex. So in x equals 3, so we can say x equals h because x equals 3. So the x coordinate of the vertex is the equation of the axis of symmetry of the parabola. We see that line defined by x equals 3. Now when a parabola is concave up, so the value of a is greater than 0, so like you see for this function on the left, the y value of the vertex is called the minimum. So the vertex here is 0, 1, so this function has a minimum, the lowest value of y equals 1. Now when a parabola is concave down, the value of a is less than 0, so the value of a is negative, like you see in this function, y equals -1/2 x squared minus 1. The y value of the vertex is called the maximum. It's the highest point of that parabola. So here we have a maximum, and that vertex has coordinates 0, -1. So the maximum is y equals -1. Now look at the functions here. We have y equals 1/2 x squared plus 1. So this function has not been reflected, but it has been vertically compressed, meaning it did not get stretched towards the y-axis, but it got stretched away from the y-axis closer to the x-axis. So it's been vertically compressed, as has the function on the right, except when it was vertically compressed, it was also reflected vertically as well, and then shifted down 1 unit. Whereas after the function on the left was vertically compressed, it was shifted up 1 unit. So now let's try a couple problems. Number 1 says identify the axis of symmetry in the vertex of f of x equals x minus 3 squared minus 1. Well, for this first part, the axis of symmetry, we can remember that it has the formula of x equals h. So we know that h in this case is 3 because our formula goes x minus h. Well, that's saying x minus positive 3, so h equals 3. So x equals positive 3. So there's our axis of symmetry, our A of S. So next, we want to identify the vertex. Well, we know h is 3, now we just got to identify k. Well, k is right here, and it's negative 1. K is negative 1, so the vertex of the function is 3, negative 1. Now number 2 is asking us to create an equation in vertex form with vertex negative 2, 5. Well, it helps to remember what our vertex form is. Remember, it's y equals a times x minus h squared plus k. So we know h is negative 2 and k is 5. So we can make up any number for a. It's not going to change the values of our vertex. So we could say y equals, we can say a is 1. So we don't even have to write that if a is 1. X minus negative 2, well, that will give us x plus 2. And then k is 5, so plus 5. Or we could say, again, we can make up any value of a. We could say y equals, I don't know, negative 2 times x plus 2 plus 5. And something I forgot was to include the squares right here. Alright, because it's quadratic, that exponent of 2 is crucial. Without that exponent of 2, it would just be a linear function. And that's not what we're talking about right now. So any of these functions I just wrote are okay. Now these problems just ask us to identify the vertex and the transformations of the parent function. So for number 1, the vertex, remember hk, well, h is positive 2 and k is positive 1. There's the vertex. Now we see that the parent function, remember y equals x squared, that's the parent function of the quadratic family. It is being shifted to the right 2 times because h is 2, so it's being shifted right twice, and it's being shifted up 1 unit. Now for number 2, h is positive 7 and k is negative 12. So there's our vertex, positive 7, negative 12. Now if it said x plus 7 in parentheses, remember h would be negative 7 because of that form. Now the parent function, we see that a is 1/2, so it has been vertically compressed by 1/2, and that parent function has been shifted to the right 2 units and down 12 units. So I hope that was a helpful refresher from some things we saw in Unit 1. Now the last thing we're going to do here is discuss how to graph a quadratic function in vertex form. And I don't think you'll think it's too terribly difficult. So we're going to graph the function y equals x plus 2 squared plus 1. And what I'm going to do first is identify the vertex. So the vertex is going to be hk, and h in this case is negative 2 because of x minus h. X minus negative 2 is x plus 2. So h is negative 2 and k is 1. So negative 2, 1. Now the axis of symmetry is also going to be very important here. It's x equals negative 2. So I'm going to plot that point, negative 2, 1. So negative 2, up 1. There's our point here. And the axis of symmetry is going to run right down through the vertex, vertically through that vertex. Now, what I'm going to do next is I'm going to make a t-chart. So x, y, and I'm going to put the vertex right in the middle of that t-chart, negative 2, 1. So I want to plot a total of 5 points. But I'm going to show you how I only need 2 other points in the t-chart. So I want to pick values of x that are greater than -2. So a value of x that's greater than -2 would be -1. So I'm going to substitute -1 into this function. So y equals -1 plus 2 squared plus 1. So -1 plus 2 is 1. So we get 1 squared is just 1. So y equals 1 plus 1. Well, then y equals 2 when x equals -1. Then I'm just going to plot that point, -1, 2. Now, a number that's greater than -1 is going to be 0. So now I can just substitute 0 in here. I'll say y equals 0 plus 2 squared plus 1. Well, 0 plus 2 is 2, and 2 squared, so this is 2. 2 squared is 4. So 4 plus 1, we get y equals 5. So when x is 0, y equals 5. So 0, 5 is the next point I'm going to plot. Now, these points are completely symmetrical. Remember the axis of symmetry. So this point right here, -1, 2, is 1 unit over from this axis of symmetry. So on the other side of the axis of symmetry, I'm just going to go 1 unit to the left. Since this point was 1 unit to the right of the axis of symmetry, I'm going 1 unit to the left, and we have our fourth point, and that's -3, 2. So I can put that right here, -3, 2. And then we have 0, 5. Well, that's 2 units away from the axis of symmetry. So I'm going to go 2 units to the other side. 1, 2. So now I have 5 points, just like I wanted earlier. So now I'm just going to draw a parabola through those points. And there we go. There's our graph of y equals x plus 2 squared plus 1. So I hope this video was helpful for you. If you have any questions, I encourage you to rewatch the video and try to figure those out. But also, just be ready to ask me in our next class period. And make sure you're prepared to work. Good stuff today. Thank you, Collegiate Scholars.